Hello, statistics and pre-calculus. Welcome to video 2 on 5.2, inverses of functions. I know I said in the last video that this was only going to be 2 videos for this lesson, but we're definitely going to have a third video and perhaps even more. This is a pretty bulky unit and we want to make sure that you get this right. So today we're going to be covering the inverses of functions and specifically one-to-one functions and their inverses. As a recap, in our last video, we found the inverse of this relation here. We were given these input and output values, and we found the inverse of the relation by essentially flipping the input and output values. -4, -3 became -3, -4, and so on. Now, if this were a function, the only thing that would change is really the notation. Here we have our domain and our range, our inverse function, its domain and its range, where the values are simply switched. Now, the notation for a function is, of course, f of x. The notation for the inverse function is this. Now, this is a little bit confusing. I know it looks like f of x raised to the -first power. However, this is simply how we notate the inverse of a function. So do not try to raise your power to -1. So because each input value has exactly one output value that isn't repeated in these sets, this is called a one-to-one function. The inverse of one-to-one functions are also functions. This is in contrast to a many-to-one function like this one. So here we see that instead of 4 corresponding to 1, 4 also corresponds to this 2 here. So finding the inverse of this relation is the same, but this function's inverse is not a function because it is a many-to-one function. This is an important distinction and all we're really going to say about many-to-one functions for now. Now, looking at an actual graphical representation of a function and its inverse, we're going to move to the example on page 268, which has taken the sets that we were given earlier and plotted them on this graph here. So we see that this is just another way to write these points here. So to find our inverse of this function, we're going to simply reverse our x and y values like so. So our first point, -4, -2, becomes -2, -4. So on our graph here, -4, -2 is right here, -2, -4 is here. Our second point, 0, -3, becomes -3, 0. -3, 0 is right here. 0, -3, the original function, is here. 1, 2 becomes 2, 1. 1, 2 is right here. 2, 1. Did you guys see me almost put it at 2, -1? This is 2, 1 here. Finally, 4, 1 becomes 1, 4. 4, 1 is here. 1, 4 here. So there might be another thing you notice here. It looks almost like a reflection. Remember in our reflections over the y and x axis, this kind of looks like that, but instead of reflecting over the y or x axis, we're reflecting over this dashed line here. Well, this dashed line is y equals x. Now, because the ordered pairs in a function are flipped or reversed during their inverse, this makes sense. So you can think of an inverse function as the graph of your original function reflected over the y equals x line. So that's going to conclude this video. Good work, guys.